Okay, so this is the last part of Chapter 8, and what we need to talk about is the determination of whether or not a linear model is actually appropriate. Because when we talk about the three things we need to talk about when we talk about a relationship, such as form, direction, and strength, when we talk about form, we say, oh, it's linear or it's not, but maybe even though it looks like a linear model, maybe a linear model is not the best model that we should be using here. Maybe we should be using another model. So that's the question that we're going to look at. Because say, for example, that I'm looking at a data set that looks something like this. And as I look at that, I say, hey, you know what? There's a curve, so that's parabolic in shape. That might be the equation y equals x squared. And even though it's only half of the parabola, it's still parabolic in shape, and maybe a line is not the best fit. Now, when we look at this, we say, oh, yeah, no, this is a curve. It's pretty obvious. But say, for example, that we're looking at a relationship on the calculator, and I'll go to Stat and Edit, and in L5 and L6, I have, actually, in L5 I've got 1, 2, 3, 4, 5, and in L6 I've got L5 squared. So I've got 1, 4, 9, 16, and 25, because that'd be the square of 1, 2, 3, 4, 5. And what I'm going to do is I'm going to graph that. And granted, we know that that's x squared, so we know that it's a parabola. But when I graph this, and I have L5 versus L6, and you know what? Let's do the correlation coefficient on this too. Let's find out what that is. So even before I graph this, I'm going to go to Stat, I'm going to go to Calculate, I'm going to do 8 for linear regression, a plus bx, L5, comma, L6, comma, y1, because I'm going to dump the equation into y1. It's variable, it's a y variable, it's a function, y1. And I'm going to hit enter, and we get, there's my y-intercept of -7, there's my slope of 6. But notice that r is 0.98. Man, that's really strong. So of course, we're saying r is how we determine whether or not a correlation is possible here, and whether or not we've got a linear correlation. The answer is no, it's not. We have to look at the graph. All right, so let's look at the graph. So I'll go to stat plot, I'll plot 5 and 6, and of course zoom 9, and everything should drop in there, and there's my graph. And because of the scale of the graph on the calculator, that curve is not readily apparent. And we say, oh, you know, we've got a really strong correlation, a line fits there really nice, maybe a linear model is appropriate. But this isn't how we determine. What we have to do is we have to look at the residuals. And by looking at the residuals, what we're doing is we're looking at the errors. We're saying, are the errors there randomly? Because if the errors are random, that means that a linear model is appropriate. And what I mean by this is, if I'm looking at the residual plot, and what I'm going to do is I'm going to plot the independent variable x versus the residuals, versus the errors. If I can determine from that where the next point is going to be, or should be, from that graph, then a linear model really is not appropriate here. It should be completely random. So, what's convenient is that every time that you do the residual plot, the linear regression, every time you do the linear regression, in the list menu for the calculator, it calculates the residuals for every single one of those values. And here my list is called resid. And I've got a bunch of other lists here, but my list is called resid. And just like every time you do one variable stat, it replaces x bar with the current mean, every time you do the linear regression, it replaces the resid list with the current residuals. So what I'm going to do is I'm going to graph L5, which is my independent variable or my explanatory variable, versus the residuals. So I will do that by going to list, and I will choose residual, which for me happens to be number 8. Or apparently it's freshman year GPA. Let's try this again. List 8. Or we'll try it one more time. Let's see if we can just clear that. List 8. There we are, resid. And I will zoom 9 because, again, things change. So my scale is going to change here. So I go to zoom 9. And what I see here is this line actually represents the line of best fit. And this is how the residuals line around the line of best fit. And there it is, right there. And the question is there a pattern? Can I predict where the next value is going to be? And the answer is yeah. The next value is probably going to be up here where my finger is, which means that a linear model is not appropriate in this situation. And we know that because we knew we had a parabola. So if I wanted to use a linear model, what I'd have to do is I'd have to re-express the data some way, which is the next section that we would do in class. We don't have to do that now, but we need to look at that residual plot. And every time that you are asked, is a linear model appropriate, you have to make a residual plot. And in order to verify that, you would have to say a linear model is not appropriate. And then you would have to draw the residual plot. And it doesn't have to be perfect. You could draw something like this. Here's the line of best fit. There's the residual plot. Linear model, not appropriate. That would be a perfect answer. Let's, for example, take a look again at freshman year GPA, freshman year GPA and SAT scores. But as I'm thinking about that, what I have to do is when I plot the residuals, I have to turn around and find the residuals for that data because my residuals right now are for L5 and L6. So what I'm going to do is I'm going to, again, do my linear regression, stat calculate 8, 4, and my data is, again, into L1 and L2. And I'm also going to put the line of best fit in there. So I would go to variable, it's a y variable, it's a function, y1, and I get the values and let's see if everything matches up here. We've got a y-intercept of negative 1.47, which is the same thing we've had for a long, long time. 0.0039 is my slope, my correlation coefficient 0.816. And now I'm going to plot the residuals. I'm going to plot the SAT scores versus the residuals. So here I go. I'm going to go to stat plot, and I'm going to plot L1, versus the residuals, and I can just leave resid there because it's been reassigned with all the data. So I'm just going to leave that as is and zoom 9, and here we go, and we say, okay, is a linear model appropriate? Is there a pattern to this residual plot there? And you're saying no, and I'm saying, but of course there is. Look at this, and let me draw on this, and you can see the residual plot here. As I get the pen, you can see the residual plot. There it is. Look. It's an upside down goldfish cracker. So of course there's a pattern to the residuals, right? No. This is not a Rorschach test, one of those ink blot things where you look at the ink blot, you sit there and say, oh, what do you see? Oh, I see death. And what do you see on the next one? Oh, I see death. And what do you see next? I see death. Because you can take your Twilight stuff away. So this is not a pattern. We're looking for a graphic pattern. And what would that mean? That would mean a mathematical pattern, something that would look like this. If you saw, here's your line of best fit. If you saw a parabola in the residuals, linear model, not appropriate. Line of best fit. If you saw a linear pattern in the residual, line of best linear, if you saw a line in your residual, then a linear model is not appropriate. If I saw it where it went bounced back and forth around the line of best fit, linear model, not appropriate, because I can predict where the next one's going to be. If I saw something where it was close and then it starts to spread out, forming like a cone or a greater than sign, linear model, not appropriate. I could predict, oh, it's going to get farther and farther away. There should be absolutely no pattern to the residual plot, meaning that it should ideally, it should be like a great big rectangle of stuff. Or, as we like to say, it would be the one where someone sneezed on the calculator screen. But you have to do the residual plot. If it asks you, is a linear model appropriate? You have to do the residual plot. You have to graph the residual plot, and you have to draw it so that we can tell and we can verify that that was done. It needs to be done. And time is up.